The Graphics Interchange Format is a bitmap image format that was introduced by CompuServe in 1987 and has since come into widespread usage on the World Wide Web due to its wide support and portability. The format supports up to 8 bits per pixel for each image, allowing a single image to reference its own palette of up to 256 different colors chosen from the 24-bit RGB color space. It also supports animations and allows a separate palette of up to 256 colors for each frame. These palette limitations make the GIF format less suitable for reproducing color photographs and other images with continuous color, but it is well suited for simpler images such as graphics or logos with solid areas of color. GIF images are compressed using the ʻdʒɪf lossless data compression technique to reduce the file size without degrading the visual quality. This compression technique was patented in 1985. Controversy over the licensing agreement between the software patent holder, Unisys, and CompuServe in 1994 spurred the development of the Portable Network Graphics standard. By 2004 all the relevant patents had expired. History. CompuServe introduced the GIF format in 1987 to provide a color image format for their file downloading areas, replacing their earlier run-length encoding format, which was black and white only. GIF became popular because it used ʻdʒɪf data compression, which was more efficient than the run-length encoding that formats such as PCX and MagPaint used, and fairly large images could therefore be downloaded in a reasonably short time, even with very slow modems. The original version of the GIF format was called ʻdʒɪf. In 1989, CompuServe released an enhanced version, called ʻdʒɪf, which added support for animation delays, transparent background colors, and storage of application-specific metadata. The ʻdʒɪf specification also supports incorporating text labels as text, but as there is little control over display fonts, this feature is not widely used. The two versions can be distinguished by looking at the first 6 bytes of the file, which, when interpreted as ASCII, read GIF ʻdʒɪf and GIF ʻdʒɪf, respectively. GIF was one of the first two image formats commonly used on websites, the other being the black and white XBM. The feature of storing multiple images in one file, accompanied by control data, is used extensively on the web to produce simple animations. The optional interlacing feature, which stores image scan lines out of order in such a fashion that even a partially downloaded image was somewhat recognizable, also helped GIF's popularity, as a user could abort the download if it was not what was required. As a noun, the word GIF is found in the newer editions of many dictionaries. In 2012, the American wing of the Oxford University Press recognized GIF as a verb as well, meaning to create a GIF file. As in, GIFing was perfect medium for sharing scenes from the Summer Olympics. The press's lexicographers voted it their word of the year, saying that GIFs have evolved into a tool with serious applications including research and journalism. In May 2015, Facebook added GIF support after originally rejecting support. Pronunciation. The creators of the format pronounced GIF as GHIF, with a soft GHIF, as in gin. Steve Wilhite says that the intended pronunciation deliberately echoes the American peanut butter brand, GHIF, and CompuServe employees would often say, "Choosy developers choose GIF," spoofing this brand's television commercials. An alternative pronunciation with a hard G is in widespread usage. The American Heritage Dictionary cites both, acknowledging GIF as the primary pronunciation, while Cambridge Dictionary of American English offers only the hard G pronunciation. Merriam-Webster's Collegiate Dictionary and the OED cite both pronunciations, but place GIF in the default position. The New Oxford American Dictionary gave only GIF in its second edition but updated it to GIF in its third edition. The disagreement over the pronunciation led to heated internet debate. On the occasion of receiving a Lifetime Achievement Award at the 2013 Webby Award ceremony, Will Hite rejected the alternative pronunciation, and his speech led to 17,000 posts on Twitter and 50 news articles. The White House and TV program Jeopardy! Also waded into the debate during 2013. Usage. GIFs are suitable for sharp-edged line art with a limited number of colors. This takes advantage of the format's lossless compression, which favors flat areas of uniform color with well-defined edges. GIFs may be used to store low-color sprite data for games. GIFs can be used for small animations and low-resolution film clips. GIFs are commonly used as a medium for humorous effect. One or more video sources can be edited, rearranged, or combined to create an absurd juxtaposition, to create the opposite effect intended by the creator of the original work, or to emphasize and exaggerate a minor detail. File format. Conceptually, a GIF file describes a fixed-sized graphical area populated with 0 or more images. Many GIF files have a single image that fills the entire logical screen. Others divide the logical screen into separate sub-images. The images may also function as animation frames in an animated GIF file, but again these need not fill the entire logical screen. GIF files start with a fixed-length header giving the version, followed by a fixed-length logical screen descriptor giving the size and other characteristics of the logical screen. The screen descriptor may also specify the presence and size of a global color table, which follows next if present. Thereafter, the file is divided into segments, each introduced by a 1-byte sentinel, an image, an extension block, the trailer, which should be the last byte of the file. An image starts with a fixed-length image descriptor, which may specify the presence and size of a local color table. The image data follows. 1 byte giving the bit width of the unencoded symbols, followed by a linked list of sub-blocks containing the LZW encoded data. Extension blocks consist of the sentinel, an additional byte specifying the type of extension, and a linked list of sub-blocks with the extension data. Extension blocks that modify an image must immediately precede the segment with the image they refer to. The linked lists used by the image data and the extension blocks consist of series of sub-blocks, each sub-block beginning with the byte giving the number of subsequent data bytes in the sub-block. The series of sub-blocks is terminated by an empty sub-block. This structure allows the file to be parsed even if not all parts are understood. A GIF marked 87A may contain extension blocks. The intent is that a decoder can read and display the file without the features covered in extensions. It does not understand. The full detail of the file format is covered in the GIF specification. Palettes. GIF is palette-based. The colors used in an image in the file have their RGB values defined in a palette table that can hold up to 256 entries, and the data for the image refer to the colors by their indices in the palette table. This limitation seemed reasonable when GIF was developed because few people could afford the hardware to display more colors simultaneously. Simple graphics, line drawings, cartoons, and grayscale photographs typically need fewer than 256 colors. Each frame can designate one index as a transparent background color. Any pixel assigned this index takes on the color of the pixel in the same position from the background, which may have been determined by a previous frame of animation. Many techniques, collectively called dithering, have been developed to approximate a wider range of colors with a small color palette by using pixels of 2 or more colors to approximate in-between colors. These techniques sacrifice spatial resolution to approximate deeper color resolution. While not part of the GIF specification, dithering can of course be used in images subsequently encoded as GIF images. This is often not an ideal solution for GIF images, both because the loss of spatial resolution typically makes an image look fuzzy on the screen, and because the dithering patterns often interfere with the compressibility of the image data, working against GIF's main purpose. In the early days of graphical web browsers, Graphics cards with 8-bit buffers were common, and it was fairly common to make GIF images using the web-safe palette. This ensured predictable display, but severely limited the choice of colors. Now that 32-bit graphics cards, which support 24-bit color, are the norm, palettes can be populated with the optimum colors for individual images. A small color table may suffice for small images, and keeping the color table small allows the file to be downloaded faster. Both the 87A and 89A specifications allow color tables of 2n colors for any n from 1 through 8. Most graphics applications will read and display GIF images with any of these table sizes, but some do not support all sizes when creating images. Tables of 2, 16, and 256 colors are widely supported. True color. Although the GIF format is almost never used for true color images, it is possible to do so. A GIF image can include multiple image blocks, each of which can have its own 256 color palette, and the blocks can be tiled to create a complete image. Alternatively, the GIF 89A specification introduced the idea of a transparent color, where each image block can include its own palette of 255 visible colors plus one transparent color. A complete image can be created by layering image blocks with the visible portion of each layer showing through the transparent portions of the layers above. To render a full-color image as a GIF, the original image must be broken down into smaller regions having no more than 255 or 256 different colors. Each of these regions is then stored as a separate image block with its own local palette, and when the image blocks are displayed together, the complete, full-color image appears. For example, breaking an image into tiles of 16 by 16 pixels ensures that no tile has more than the local palette limit of 256 colors. Although larger tiles may be used and similar colors merged, resulting in some loss of color information. Since each image block requires its own local color table, a GIF file having lots of image blocks can be very large, limiting the usefulness of full-color GIFs. Additionally, not all GIF rendering programs handle tiled or layered images correctly.